Hello. I'm going to go through numbers 1 through 5 in this recording. Okay? If after you see the recording you still understand a question, you need to come ask me for help. Come see me at lunch or after school. Okay, so number 1 says a catering company provides food for 3 family reunions on July 4th every year. The matrices below represent the number of hamburgers and hot dogs ordered by 3 families in 2009 and 2010. This has 3 parts. Part A says write a matrix that represents the total number of hamburgers and total number of hot dogs that each of the 3 families ordered for the years 2009 and 2010. So what you're actually going to do is you're going to add the matrices. We can add these matrices together because they have the same dimensions. Each matrix has 3 rows and 2 columns, so you can add them together. So all I'm doing is writing out the original matrices just so you can see how I'm adding them together. And what you end up doing is you just add the numbers in the corresponding places in the different matrices. So for example, I'm going to add the 50 and the 60 together because those are in corresponding places. They're both in the first row and first column. So 50 plus 60 is 110. 40 plus 45 is 85. 15 plus 40 is 55. 48 plus 40 is 88. 25 plus 30 is 55. 20 plus 40 is 60. That matrix represents the number of hot dogs and number of hamburgers each of the 3 families orders for the years. Okay, so that's number 1. That matrix represents the total number of hamburgers and total number of hot dogs that each of the 3 families ordered for the years 2009 and 2010. Okay, I'm going to do part B and C on this page just so that I have more room. Part B says how many more hot dogs did the Baker family order in 2000 than in 2009? How many more is a phrase that tells you you're going to need to subtract. You're trying to find out the difference between the two, and difference is a subtraction keyword. Okay, so the Baker family in 2010 sold 30 hot dogs, or ordered 30 hot dogs, and in 2009 ordered 25 hot dogs. So I'm just going to take 30 minus 25, and you get 5 hot dogs as your answer. You want to get in the habit of labeling your answer. Okay? It's a good habit to get into. Now, part C, the catering company predicts that in 2014, each family order 5 times, that's a key phrase we're going to come back to, as many hamburgers and hot dogs as they ordered in 2010. Based on this prediction, write a matrix that will represent the total number of hamburgers and total number of hot dogs each family will order in 2014. So what we're actually going to do is we're going to multiply the entire 2010 matrix by 5. So it's going to look like this. Okay, and we're just going to multiply each of the numbers by 5 to get our final answer. So 5 times 60 is 300. 5 times 45 is 225. 5 times 40 is 200. 5 times 40 again is 200. 5 times 30 is 150. And 5 times 40 again is 200. And this matrix represents the catering company's prediction in 2014 that they will order 5 times as many items as in 2010. Okay, the next question. Stephen bowled at 160, 180, and 210 in his first 3 games. What score would Stephen have to bowl in his 4th game for his 4-game average to be 180? Explain how you determine your answer. Use word, symbols, or both in your explanation. When you have a BCR and ECR in algebra, the explanation is really, or justification is really just showing your work. So that's all I'm really looking for when I grade these exams, is that the student shows their work, or you show your work. So this problem should look familiar once you see it. We did a number of these problems in class throughout the year. So average, in this case, is another way of saying mean. And that's what we're actually trying to find. This average represents the mean of the data. Though the word average can mean mean, median, or mode. In this case, it represents the mean. So notice that I am adding the 3 scores together plus an unknown score, and I'm dividing that by 4 to get a mean of 180. And I'm going to go and solve this equation. First thing I'm going to do is multiply both sides by my denominator, which is 4. They cancel out on this side, leaving me with just 160 plus 180 plus 215 plus x is equal to 720. When I add the 3 bowling scores together here, I get 555. So at this point I'm left with a one-step equation. I'm going to subtract 555 from each side. And I get x equals 165 is my answer. Okay? Again, if you're not sure how to do that, you should come see me for help. Okay, number 3 says Jack plays basketball. After 9 games, he is averaging 19 points per game. If x represents the following... Sorry, let me do that again. If x represents the number of points that he scores in his 10th game, which of the following inequalities represents how many points that he must score in his 10th game in order to average at least 20 points per game? And again, that average represents the mean. So we're trying to find the mean here. Now, I purposely covered up the answers because one strategy on an algebra exam, or any exam for that matter, especially when you're doing math, is to actually cover up the answers before circling an answer. A lot of students get in the habit of just circling an answer without going through and doing the work. So we want to get out of that habit and make sure we're doing the work we need to solve each of these problems to ensure our maximum amount of success. Okay? So first thing I'm going to do is I'll multiply 9 times 19. It's going to give me the number of points that Jack has so far. Okay? When I multiply 9 times 19, I end up with 171. Okay? So now I'm going to set up an equation. I'm going to say 171 plus x, and it says, how many points must you, let's say, it says which of the following inequalities, so it's 171 plus x is greater than or equal to 20 points per game times 10 would be 200 points. And I'm going to solve this one-step inequality, and x has to be greater to or equal to 29 points. Okay. Now that I have the answer I'm looking for, I can uncover the answers and see that it's going to be D. Okay. Let's talk about number 4. The table and box and whisker plot show the number of hours Suchita worked each week at her summer job. Jeff looked at the box and whisker plot included the number of weeks Suchita worked 19 hours or less was greater than the number of weeks she worked 23 hours or more. Is Jeff's conclusion correct? Use mathematics to justify your answer. Okay? He is not correct. Okay? This is one of those problems where you would actually, it would benefit you greatly to put something in your calculator, but in this case, we don't really need to put it in the calculator. We're actually just going to interpret the box and whisker plot. Okay? So if we look at find 19 on the box and whisker plot, it's going to be right here, and we draw a line up. We see that it's in the middle of this first box, which means it's in the middle of the lower 50%. Okay? If we find where 23 hours or more is, we see that that is actually where the median is. Okay? In a box and whisker plot, the median splits the data in half. That means half the data is above the median, half the data is below the median. So in this case, Suchita worked 50% of the weeks. Let me say that again, okay? She worked 23 hours or more 50% of the time. She worked 19 hours or less than 50% of the time. So Jeff is incorrect, okay? The median is 23, means she worked 23 hours or more half the time. It also means that she worked 23 hours or less half the time, but looking at the chart, there were times when she worked 20 or 22 hours, so we know that that means she worked 19 hours or less often than she worked 23 hours or more. Okay, so here is where you have to use your L1, L2 in your calculator. I'll just give you a quick review. So if you hit Stat, Edit, because it's a frequency table, you have to put the number of hours in L1 and the number of weeks in L2. And when you're done that, you hit Stat, you get a 1 VAR. Okay, let me start that again. Once you put the data in the L1 and L2, you hit Stat again. You get a 1 VAR stat. And then you have to put L1, L2 after it. Okay. The line on the top, the X with the line on top is the mean. If you go to the bottom, you're going to see MED, which represents the median. Mode you still have to figure out yourself without using the calculator. Okay? So in this case, we get a mean of 19. We have a median of 23, as we discussed on the other side. Our mode is 26 because that occurred 3 times based on the frequency table. Now the second part of the question, which measure best represents Suchita's typical work week? Okay, in the case of this data, there is an outlier. Okay, there's actually probably 2 outliers, but the first outlier where they worked 1 week for 1 week she only worked 1 hour, that is an outlier. So we're going to pick the median. The median is the best piece of data, the best measure. Because there is an outlier or a piece of data that does not go with the rest. If there was no outlier, we would pick the mean. Last question in this recording. The box and whisker plot below show the points scored by 2 basketball teams over the course of the season. Derek looked at the plots and stated he felt that Maryland was the higher scoring team during the season. Is this a valid conclusion? Use mathematics to justify your answer. Okay, this is not a valid conclusion. Okay. Duke has a higher median and a higher upper quartile and a higher lower quartile, which means for the majority of the time, Duke scored more points. While Maryland has a higher upper extreme at 95, most of the games, based on the box being lower than Duke's box for the most part, had scored less points than Duke. So if I was looking for an answer like this on an exam question, I'd be looking for a couple things that tells me that the student understands that Duke scored more points, or that the box and whisker plot shows that Duke in general scored more points. So I'd be looking for something like this. Duke has a higher lower quartile, median, and upper quartile. Notice the question states give more than one reason. So I've given 3 reasons there. So that would be sufficient to get full credit on this question.